Hello everyone, how's it going? My name is Dan the Tutor. Today we're going to be looking at the law of sines and law of cosines for pre-calculus and trigonometry. Now I am going to split this up into multiple videos because there's a lot here, but today's video is going to focus on just the law of sines. So in this video I'm going to be explaining the formula, when to use the law of sines, and then we'll look at a couple example problems. So first, here's the formula. If you have some triangle, and it doesn't have to be a right triangle, it's any triangle. That's a terrible triangle. Let me try that again. Much better. That's a triangle I can live with. And you have three sides and three angles. Typically we call the vertices or the angles capital A, capital B, capital C. And then we typically call the sides A, B, C, all lowercase. Notice that all of my angles and the sides are opposite of each other. In other words, capital A is opposite of side A, angle B is opposite of side B, and angle C is opposite of side C. So that's typically the notation we use, and it's definitely important to use the law of sines. And here's what the law of sines says. If you take the sine of angle A and divide it by side A, it must be equal to sine of B over lowercase b, and it also must be equal to sine of capital C, angle C, over lowercase c. This is what the law of sines says. Now when you actually use the law of sines, you're not going to be doing all three at once. There's no reason to do that. You just need to set two of them equal to each other, and the third one you can find later. Now another thing worth mentioning is that because of the reciprocal property, and even if you don't know what that is, just take my word for it, it turns out that the reciprocal, in other words, you flip everything, this is true as well. So really you get to pick your favorite, whether you like the top one or the bottom one here. They both work. I'm going to be using the top one today because that's what I learned in high school, but you can do whatever you want. Now the other thing I want to say about the law of sines is that we use the law of sines to solve triangles. What does solving a triangle mean? It means that we want to find all of the angles and all of the sides. So basically what I'm saying here is that I give you a triangle, and let's say I know some things for this triangle. I know this side is 120 degrees, I know this side is 6, and I know this angle here is 32 degrees. This is a perfect example of when to use the law of sines. Because why? Well, let's see what I have. Let's call the vertices capital A, capital B, and capital C. And then I'll call the side lengths lowercase a, lowercase b, and lowercase c. Notice that, again, all of my sides are opposite of the angles. Like, for instance, angle A is the opposite of side A. And it's super important that you do that. You'll also notice that in this example, C is 6. And when I say solve triangles, I'm saying find the remaining sides and angles. In other words, there's three things I don't know right now, and I'll circle them. I don't know angle C, I don't know side length B, and I don't know side length A. We can use the law of sines to find all of these things, and the reason why is because what information I gave you. If you look here, I have an angle, I have a side, and then I have another angle. If we remember our triangle congruency theorems, you would call this ASA, angle, side, angle. And as it turns out, angle, side, angle, and angle, angle, side work great for the law of sines. So we're going to use law of sines whenever you have these two triangle congruency theorems. Then if you have side, 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 or side, angle, side, for these you're going to use the law of cosines, which I'll cover in the next video. And then in the last video, I'll talk about SSA, which we would never say the other way around, right, kids? Yeah. And this is known as the ambiguous case of the law of sines. And what the heck does ambiguous mean? Basically, when I make that video, it's going to be like 20 minutes long, and we're going to have to look at like 5 problems to see all the different scenarios you can have. But SSA, side, side, angle, is the worst. We hate it. So in today's video, I'm just talking about normal law of sines problems. In the next video, law of cosines problems. And then in the third video, the ambiguous case of the law of sines. Everyone good with that? Okay, great. If you have a problem, you can submit a complaint. And the Human Resources Department of Dan the Tutor will look into that very thoroughly. And by that, I mean I'll put it right in the recycling bin. So now let's look at that example I just said a minute ago. 120 degrees, 32 degrees, and 6. And now I'm going to label exactly what I have. I have angle A is 120 degrees, side length A is unknown, angle B is 32 degrees, side length B is unknown, angle C is unknown, and side C is 6. Now there's actually a problem with using the law of sines right now, and that's the fact that I don't have everything I need. In other words, to use the law of sines, I either need both A's, both B's, or both C's. So I actually can't use the law of sines quite just yet. But the good news is there is an easy way to find angle C, and that's remembering that all angles in a triangle add up to 180. So 32 plus 120 is 152, and then 180 minus 152, that's 28. So in other words, side angle C, the missing angle, is 28 degrees, and I'll fill that in right there. So now I have side C and angle C, so I can use law of sines to find A and B, the missing side lengths. And here's what I'm going to write, one at a time. I'm first going to do sine C over C equals sine A over A, and then after that I'll do sine C over C equals sine B over B. And that's how I'm going to find both missing sides. So the sine of 28 degrees over side length C was 6 equals sine of A, which was 120, divided by side A, which is what I'm solving for. So to solve this now, I'm going to cross multiply, and on the left I'll have A times the sine of 28 degrees equals, on the right I have 6 sine of 120 degrees. So if I want to solve for A, I just have to divide both sides by 28 degrees. I mean the sine of 28 degrees. I'm going to plug this in my calculator now, and we'll be able to get this in one simple step. And I got an answer of 11.07. So there's side length A, one of my missing sides, and now I just need to find B. And as I said, I'm going to use sine C over C equals sine B over B. And sine C again was 28, and C was 6. And that's equal to the sine of 32 degrees divided by side length B, which is what I'm solving for. Once again, I'm going to cross multiply. So I get B sine 28 degrees equals 6 sine of 32 degrees. And again, I'm just going to divide both sides by 28 degrees. I mean the sine of 28 degrees. Plug this in my calculator, and we'll get a final answer. And I get B equals 6.77. And there, that's all my missing sides and angles for this triangle. I now know everything for this triangle, and I'll even fill it in just to show you what it looks like. So we just said B was 6.77, we said A was 11.07, and the missing angle was 28 degrees. So there, you can know every side and every angle of a triangle as long as you have one of the triangle congruency theorems, which again I listed out right here, as you can see. So now let's look at another one. For this one I have a 25-degree angle here, a 70-degree angle here, and a 15 side length here. And I'm going to tell you I'll call this A, this B, and this C. And then of course the opposite of A is here, opposite of B is here, and the opposite of C is here. And I would again like to find all the missing sides and angles. So this time, why don't you pause the video and give this a try and see if you can do it for yourself. Okay, I'm assuming you paused the video and now you're unpausing it to see the solution. Here's what we do. First, if you want, you can find angle B by saying 25 plus 70 is 95 degrees. And then if you want to find the missing side, you do 180 minus 95 and you'll get 85 degrees. So in other words, angle B was 85 degrees. Okay, hopefully you got that. And now we're going to do the law of sines. And the good news is here, it's basically the exact same strategy as last time, where we'll say sine of C over C, where we have both the angle C and side length C. So we're going to do sine C over C equals the other two, sine A over A and sine B over B. But first, A. So I'm saying the sine of 25 degrees divided by 15 equals the sine of A, which we're saying A is 70 degrees, divided by side length A. Again, I cross multiply. A times the sine of 25 equals 15 sine 70. Divide both sides by the sine of 25 degrees. I then plug this on my calculator, and I get a side length of 33.4, and there's my side length A. And now just one more, we gotta do B. Sine of C over C equals sine of B over B, where C is still 25 degrees, and lowercase c is still 15, equals sine of B, which we solved for, it was 85, divided by B. Again, I cross multiply. B times the sine of 25 degrees equals 15 sine of 85 degrees. And then you just divide, blah, blah, blah. Not too bad. Law of cosines is much worse, by the way. And I plug this in my calculator, and I'll get a final answer of 35.4. And there we go. There's our answer for this one. Now, one more thing I want to pay attention to for both this one and the first one we did. What did I give you? I gave you this guy, and this guy. In other words, that's an angle, and a side. This is angle, angle, side. In the first one we did, this one right here, I gave you this angle, and this side. In other words, angle, side, angle, or ASA. And that's the point I was making earlier. You can only use law of sines for ASA and AAS. So sometimes they don't tell you to do law of sines. Sometimes you have to figure out for yourself, but this is how you determine if it's law of sines or law of cosines. And now we're just going to do one more, and I would recommend for this last one that you confirm that this is in fact either angle, angle, side, or angle, side, angle. And the problem will look like this. I've got a 62 degree angle, a 54 degree angle, and this side is 9. And I'm going to call this A, B, C. And again, I would like to find the missing sides and angles. So go ahead and pause the video, try it for your own, and then unpause it when you're ready to see the solution. Okay, and here's the solution for this one. So first, we're going to find angle A again by saying 62 plus 54 is 116. Then we're going to say 180 minus 116 is equal to 64 degrees. So angle A, 64 degrees. Also, remember, just real quick, this was an angle, a side, and an angle. So this was ASA, so we could do law of sines in the first place. Great. And now we're going to say, for law of sines, we're going to be using A this time because we have angle A and side length A. Hopefully you realize that. So it's sine of A over A equals, we'll do B first. So sine B over B. So I'm saying sine of 64 degrees divided by, that's 9, equals the sine of 54 degrees for B divided by side B, which is what we're solving for. Cross multiply. B times the sine of 64 degrees equals 9 times the sine of 54 degrees. And then you just divide both sides by the sine of 64 degrees. And let's see what we get here. And we'll get an answer of B equals 8.10. And there's that side length. And then just one more to go. Now we're doing sine A over A equals sine C over C. So the sine of 64 degrees over 9 equals the sine of, what was C? C was 62. So 62 degrees over C. Cross multiply for the last time today. C times the sine of 64 degrees equals 9 times the sine of 62 degrees. And so C is going to be 9 sine 62 divided by the sine of 64. And if I plug this in a calculator, I will get 8.84 as my side length. And there we go. There's all the problems I want to look at today for the law of sines. Thank you all for watching. In the next video, we're going to be covering the law of cosines. I'll see you there. Until then, have a good day, and bye-bye.